Good morning, class. We were busy with functions, correct? So let's get straight into it. You got your test you wrote yesterday. I'll send the memo to the WhatsApp group, okay? So yesterday we spoke about hyperbola graphs, not so? Did we answer the questions with regards to the hyperbola graph? Okay. Then the day before that, before yesterday, or for yesterday's homework, I asked you to do 8.3 as well. But we didn't get time to actually answer these questions, not so? So what I'm going to do is I'm going to first do 8.3. So exercise 8.3 is on page. Sorry? .70. Okay, so the question says draw the graph of the parabola showing the intercepts of the axis, the equation of the axis of symmetry, the coordinates of the turning point. Yeah? Frozen. Cold, ne? So it's frozen. Thank you. Okay, so let's just do this quickly. This is number 1. Alright. So the first graph, we're going to work out our x-intercept. Well, firstly, the shape of this graph. The shape of the graph is what? The graph will be smiling. Not so? So smiling. X-intercept, we let y equal to 0. So 0 is equal to 2x squared. Divide by 2. X squared is equal to 0. The square root thereof, x is equal to 0. Not so? Then, y-intercept. What do you do for y-intercept? X equal to 0. So y is equal to 2 times 0 squared, which is 0. So, if you look at this graph, there's enough information to draw this graph. Is it? No, it's not. Remember, that's your origin there. Can you see that? We know the graph is smiling. So you're going to go through x value of 0 and a y value of 0. So this is what your graph is going to look like. Not so? But is that not also suiting the same conditions? Can you see that, people? Which means to say that we need a more defined part of this graph. We need another point at least on this graph, to be fair. Not so. So what do I say? We let x equal to 1. We let x equal to 1. We say let. Then y is equal to 2 times 1 squared, which is 2. So it's 1 and 2. So if x is 1, y is 2. You see that? Just by approximation. There we go. You guys understand? So let's answer these questions pertaining to this graph strictly. I gave you a list of few questions yesterday, or the day before. Not so? So, what was the first point I asked? The domain. What's the domain of this graph? X an element or real numbers. What's the range? Y is greater than or equal to? Greater than or equal to? Greater than or equal to 0. Okay? What's the next thing I ask you? With the graph increasing. So this part of the graph it is decreasing. So it's decreasing for x's less than 0. So it's decreasing for x is less than 0. Where is it increasing? X is more than 0. Turning point? What's the coordinates of the turning point? 0 and 0. This graph has a minimum value of 0 and occurs at x equal to Nick. What's the next thing? Axis of symmetry, which is the equation of the axis of symmetry. X is equal to 0. Next, which f of x equal to 0. Which f of x less than and equal to, is this less than? Less than equal to 0. Which f of x more than 0. So which f of x equal to 0? Dismiss the y is equal to 0 lines to do with that line, not so. Which f of x equal to 0? At 0. Which f of x less than or equal to, is there any part less than 0? Is there any part under this line of y is equal to 0 here? No. Is there a part that is equal to 0? Yes. Which is 0. So in other words, x is equal to 0 is what that solution is. Okay. No part of the graph is less than 0, but there is a part of the graph that's equal to 0, and that part is 0. Which f of x greater than 0. So in other words, can I consider this point of 0 here? No. Anything above that, the line, will be acceptable. Not so. So we can say that x is an element of all real numbers. However, x is not equal to 0. And there we go. Okay. Or we could have said x is less than 0 or x is more than 0. Right, let's look at number 2.
So,
Yes?
let's just confirm something about is the range always 0 and y is less than or greater than 0?
No. Depends on the turning point of it. So there is the y coordinates of the turning point. Okay, you will see the change now happen. Okay. Let's look at B. Y equals x squared minus 4. So what's the first thing? The shape of the graph. The graph is smiling. Secondly, x-intercept. What do you do for x-intercept? Let y equal to 0. So 0 is equal to x squared minus 4. Difference of two squares. So x and x, 2 and 2 plus and minus. So x is equal to 2 or x is equal to negative 2. Thirdly, y-intercept. What do you do for y-intercept? X equal to 0. So y is equal to 0 squared minus 4, which is negative 4. Enough information to draw the graph, not so? So, the graph is smiling, it's cutting at negative 4, negative 2 and 2. So from the turning point we know we draw. There we go. Okay, going through that minus 2 and 2. X and y. Okay. All okay with that? Okay, this was P. Why is P, which is y is equal to x squared minus 1. Okay. Right, what's the first question? Domain and range. Domain, which is an element of all real numbers. Why? Because it's going from negative infinity to positive infinity. What's the range of this graph? Y is? Now you see the range of all possible y values. Does this graph exist at negative infinity? No. Where does it start existing at? Negative 4 onwards. So in other words, y must be more than or equal to negative 4. You see, so it's not always to do with 0. The next thing? Increasing. Okay, increasing. So it's increasing for x's more than 0. Or is it decreasing? X is less than 0. Starting point? 0 and negative 4. This graph will have a minimum value of negative 4 and occurs at x equal to 0. Next, f of x equal to 0, f of x less than or equal to 0, and f of x more than 0. Okay. So is f of x equal to 0 on this line here? Okay, this is the y is equal to 0 line. So whichever part of the graph goes through 0 is going to be considered. So what is that solution? X equal to negative 2 or x equal to 2. Which f of x less than 0, less than equal to. So I'm including 2 and whatever is below the line. Not so. The solution together or apart? It's together, so I write it together as well. Okay. So it's from negative 2 to 2. X must be greater or equal to negative 2 but less than equal to 2. Y equal as well because I'm considering that solution of minus 2 and because there's equal as well. Can you see them? With f of x more than 0, so is this part of the graph. So in other words, x must be less than negative 2 or x must be more than 2. Okay. Any confusion here? No? You all okay with that? Right, so from here, I'm not going to do the interpretation. I'm not going to write it down. I'm just going to call it out. Is that okay? So we have done it on all the other graphs. At this point, we are mainly focusing at drawing the graph. Not so, but we are revising the other aspects that we have been taught as well. So we start here. The graph is frowning. Why? So it's negative. It's sad graph. Secondly, x-intercept. What if we x-intercept? Then y equal to 0. So you got 0 is equal to negative x squared plus 1. If they get over the equal sign, x squared is equal to 1. Square root, what must I not forget? Plus minus. Or I could have taken different, first divided by negative 1 and then taken difference of 2 squares. We could have done that as well. The next step is your y-intercept. What do you do for y-intercept? With x equal to 0. So y is equal to negative 0 squared plus 1, which is 1. And people, this is enough information to draw the graph. Okay, the graph is frowning, it's turning at 1 and negative 1. Okay. You all agree with that? Right. What's the first question? The first question says determine the domain. What is the domain of this graph? X is an element of all real numbers. What's the range of this graph? Y is less than or equal to 1. Next, increasing. It's increasing for x's more than x's less than 0. Where is the graph decreasing? X is more than 0. Next, turning point. Coordinates of turning point 0 and 1. The graph has a maximum value of 1 and it occurs at an x value of 0. Equation of the axis of symmetry. X is equal to 0, which is your y-intercept. With f of x equal to 0, x is equal to negative 1 and x is equal to 1. With f of x less than and equal to 0, is this part here, not so. Less than equal to 0. So in other words, x must be less than and equal to negative 1, or x must be more than equal to 1. And the last one is f of x greater than 0. It's a continuous solution. With f of x greater than 0, it's from this point here, it was more than this part on top. Okay, so it's from negative 1 to 1. X is greater than negative 1 but less than 1. Okay, let's look at, we're going to move a bit faster now through D. Oops. D, you got y is equal to negative x squared minus 1. So firstly the graph is frowning. Secondly, you work out the y-intercept. What do you do for y-intercept? Then x equal to 0. So y is equal to negative 0 squared minus 1, which is negative 1. X-intercept. What do you do for x-intercept? Let y equal to 0. So 0 is equal to negative x squared minus 1. Take that over the equal sign, x squared is equal to minus 1. How do I get x on its own? Square root both sides. If I introduce square root, what must I not forget? Plus minus. So if you work it out, no solution. Not so? So if there's no solution, that means to say there's no x-intercept. No x-intercept. Not so? So if we try and draw this graph, you know the graph is frowning. Okay, and it's going through negative 1. So is this enough information to draw the graph? No. So what do I do now? You let x equal to 1. In that case, you got y is equal to negative 1 squared minus 1, which is negative 2. You all agree with that? So this point is 1 and negative 2. X is 1, y is negative 2. So from that turning point, it's going down there. Okay. First question, domain. X is an element of all real numbers. The range, y has to be less than or equal to negative 1. Increasing. It's increasing for x is less than 0. Where is it decreasing? X is more than 0. Turning point, 0 and negative 1. Not so. The graph has a maximum value of negative 1 and occurs at, a maximum value of negative 1 and occurs at an x value of 0. Equation of axis of symmetry. X is equal to 0. Which is your y-axis. F of x equal to 0. So any part of this graph which is equal to 0. Huh? No. So no solution. Where is f of x less than and equal to 0? What do you notice? This whole graph is below this line. Not so. So what do I say for that? X is an element of all real numbers. Where is f of x greater than 0? Is there any part of the graph that's above there? No. So, no solution. Okay. People, you guys understand? Okay. I'm sure you guys can draw E and F, no? Right. So I'm not going to still do that. Then I gave you another graph to draw, no? The hyperbola graph. No? Did we finish drawing this graph? And we discussed these graphs, no? Right. Now we're going to go to 8.3, sketching of hyperbola graphs. Okay. Sketch graphs, parabola, hyperbola. So yesterday we spoke about Remember when I did the sketch on the program, the graphing program, we spoke about how the graph changes if it's +1 or -2. You remember what happened to the graph? If it was +1, that 1/x graph actually moved 1 unit up. No, what was the graph we drew yesterday? Y is equal to 2/x, or is it 1/x? 1/x. So what happens? The graph moved 1 over. If I say 1/x +1, the graph moved 1 unit up. We said 1/x -2, the graph actually moved 2 units down, as well as what also moved up and down? The asymptote. Not so. The asymptote moved according to the value of what was added there. So with that in mind, we're going to draw this graph today, okay? Remember, we're not always going to draw a table, okay? So this is the example on page This is example 1 on page 168. Okay. So here we are told that sketch a graph of y equals -9/x + 1, showing the asymptotes axis of symmetry and at least one point on the graph. So just something you must note at this point is that if you got y equals k/x plus q, that's a graph we will be sketching now, okay? But that's your standard form of the graph. If k is greater than 0, okay, then what happens is, we leave q out for now, no? Otherwise we have to write q in as well. Unless q is equal to 0, then this will be the case anyway. Okay, if that is the case, then the graph will lie in the first quadrant and in the third quadrant. That's the graph we drew yesterday, not so? Right. So if I must make k to be negative, let me show you what happens then. So yesterday we inserted the function 2/x. Okay? So that was the graph. Not so? That's a graph in black. Now, what do you think will happen if I insert a function with -2/x? See what happens now. Let's make that pink. Do you notice? Can you see the graph in pink is the graph that she reads y is equal to, in black is y is equal to 2/x. Of course the graph in pink is y is equal to 2/, y is equal to -2/x. What do you notice, people? What's the difference? When this k value is positive, it lies in quadrant 1 and 3. But however, if k is negative, then it lies in quadrant 2 and 3. Can you see that, people? So what will happen if I move this graph 1 unit up? Then the asymptote also moves 1 unit up. Not so? The asymptote moves along with the graph. Also take note that this graph comes close to the asymptote but doesn't touch. Can you see that? So when you do the drawing, we draw the same thing. Okay? So I'll show you now how we draw that. Taking that into account. Okay? Okay, so we make the further note that if k is less than 0, which means to say it's negative, it lies in quadrant 2 and 4. Okay, for as the graph lies here, the quadrant is divided by your axis here, your x and your y axis. However, if your q value shifts, say that's your asymptote there, okay, then the graph will be drawn, say it's positive, there and here. Can you see that, people? So that is now your quadrant 1 and 3. So your quadrant is actually divided by your asymptotes and not by the x-axis and your y-axis. The reason why that is the case here in black in the first two graphs I've drawn is because the x-axis and the y-axis are the asymptotes of the graph as it stands. Does it make sense? Sorry? Okay. I'm saying here, if you got this now, no? So you got the equation of y is equal to, you got y is equal to k over x plus q. Then this your asymptote is going to move also q units up. Not so. So if that is the case, then if the graph is also going to move q units up. Not so. You understand? So if you take this graph into account here, and you shift the q units up, I'll get this graph. Not so? However, the quadrants, that remains quadrant 1 there, and this remains quadrant 3. But what I'm saying is the quadrants are not divided by the axis. It's actually divided by the asymptotes. Can you see that? So as the asymptote moves up, the graph also moves up. You understand? So that's what I'm trying to say. Okay. But you'll see now how it applies when we draw this graph. Right. The question says sketch a graph y is equal to negative 9 over x plus 1 showing asymptotes, axis of symmetry, and at least one point on the graph. So how do we start? We always start off with the shape of the graph. So you go shape. Right? If k is greater than 0, those two quadrants. Or if k is less than 0, those two quadrants. Not so. Then we work out our x-intercept by letting y equal to 0. Then you work out our y-intercept by letting x equal to 0. Okay? Then xy and then we have enough information to draw the graph. Okay. So follow those steps and draw or do the calculation for me quickly. Alright. So, firstly, what would the shape of this graph be? Which quadrants should it be drawn in? It's negative, so it's equal to drawing 2 and 4. Not so. What do we do thereafter? X-intercept. What do you do for x-intercept? Let y equal to 0. So we have 0 equals negative 9 over x plus 1. Okay? So solve for x for me. Right, so we take a 9 over, we could have taken the 1 over, it gives you 9 over x is equal to 1, which is 1 over 1, not so? Cross multiply. 9 times 1 is 9, x times 1 is x. So you're going to cut your x-axis at 9. Are you all okay with that? Next point is to work out our y-intercept. How do you calculate y-intercept? X equal to 0. What do you think? Okay. So if you do the substitution, you'll see that you'll have no solution answer there. Not so. Why? Because y 9 over 0 is undefined. So what does that mean to say? No y-intercept. So I'm calculating the y-intercept. So what do I do then? If I look at this graph, at least I would want another point on this graph. Not so. So how do we generate another point on this graph? We let x equal to 1. So do that calculation. Right, so we'll have y is equal to negative 9 over 1 plus 1, which is negative 8. So that's going through 1 and negative 8 here. Can you see that? So if we draw this graph, is your y and your x. Not so. The first thing we draw in is our asymptote. We know that the y-intercept is your asymptote, since there's no y-intercept here. And your this is your vertical asymptote. Your horizontal asymptote is what? Your horizontal asymptote is y is equal to 1. With y is equal to 1. Okay. So it's going to lie in quadrant 1, quadrant 2 and 4. Not so. So definitely it's going to cut this axis here. Would you agree with that? So, it's going to cut your x-axis at 9. Not so. So this is an asymptote and your y-intercept is an asymptote. So the graph will come close but not touch. It's going to do that then. Going to be, then we just reflect the graph on that. Okay? So now put it in the other color. Also we must note that the point 1 and negative 8 is also lying on this graph. Not so? It's 1 and negative 8. The graph comes close but doesn't touch. There we go, there's the one graph. And we just reflect the graph there. There's the other. Okay. So leave a few lines here as we're going to look at the interpretation of these graphs tomorrow. Not today, tomorrow. Okay. All okay with it? Kumalo? Doesn't even look like you're taking note, Michael. You all okay with that, people? We'll come back to the interpretation of these graphs. Okay, interpreting these graphs. So that's your exponential graph. So we're not going to do exponential now. What we're going to do is we're going to rather draw a few of these graphs. Okay. Why are you blowing so? You're tired of this maths already? Yes? My God, this is still. Okay, we rather not say it. This is exercise 8.3. It's on page. Check there, which page is 8.3 is on? 8.3 is on? 170. Okay. Exercise 3 on page 170. It says draw the graphs of the hyperbolas showing the asymptotes and any axis of symmetry. We'll talk about that tomorrow as well. And the equations, the coordinates of any intercept. So this is what we're going to do. The intercept with the axis. If there's no intercept with the axis, show the coordinates of at least one point on the grid. That's what we're doing already. The first one, the asymptotes we will be doing. However, the axis of symmetry we will talk about tomorrow. Okay? So let's look at A. We're going to draw the graph of A quickly. Draw the, so what are the steps you're going to follow? We're going to first look at the shape of the graph. And then x-intercept. And then y-intercept. And then draw. Right, so do that quickly. We'll pause the video at this point.